Welcome back. I hope you are enjoying with the problems. Okay, chapter 5. I think most of the concepts are, I can say, mostly we are solving only problems. Okay, now let's see. We are in student workbook problems, level 1. Write down problem number 1. Problem number 1. In the circuit shown below, the GNR diode is ideal and the GNR voltage is 6 volt. The output voltage V0. Okay, I think we solved it, but it is having different source resistance. This is 10 volt and now this is 1K and this is what is our GNR diode, and now the load is 1K and this is what is your V0. Actually fill in the blank. Okay, this is GATE 2015 and GNR voltage is 6 volt. Then asking for V0. Fill in the blank. Okay, now I think we already solved it, right? We should know the status of GNR diode. See, for that if you open this, then 1K out of 10, right? 5 here, 5 here. For 5 volt, GNR diode is in reverse bias, not in breakdown. At least you should apply 12 volt. We had seen this problem. Okay, exactly same numbers. Okay, fine. Therefore, now tell me what is your V0. Therefore, when Vi is equal to 10 volts, your GNR diode is in reverse bias. If that is in reverse bias, open circuit, then it is simply 10 volts, 1K and 1K, then your output voltage V0 will be, it is potential divider network, 5 volt. Therefore, answer is V0 is equal to 5 volt. No regulation. Vi changes, then V0 also changes. If you want regulation, Vi should be greater than or equal to 12 volt. Okay. The diode in the circuit given below has V on 0.7 volt, but it is ideal otherwise. Therefore, second approximation. The current in 4 kilo ohm resistor is, circuit is, this is what is a current source, ideal current source, 1 milliampere, and if you take this is like resistor, here also resistor, here also resistor. Okay, and there is a PN junction diode. This is 2K, this is 3 kilo ohm, this is 4 kilo ohm, 4 kilo ohm, 6 kilo ohm, this is 1 kilo ohm, and this is the diode. Okay, then asking for current, which is what is flowing through 4 kilo ohm. Therefore, where is 4 kilo ohm? This is what, let us say this is what is your I. Therefore, what is I? Okay, let's see. First of all, because the problem is associated to PN junction diode, if you know the status of PN junction diode, problem is over. Then it is simply network analysis. We can do nodal analysis and we can get the answer. But do you know the status of diode? We don't know. Then how to find the status of diode? That's all. The technique is, it is not straightforward, therefore we cannot visualize. For that we need to do the procedure, what I told before. Open the diode to find status, diode status. Okay, when you open the diode, what will be our circuit? Instead of writing like a bridge, what I do, this is simply resistor, and this is what is our current source. But where is your diode? Your diode is here. We are opening, and then we have a resistor here. This is what is this. Therefore, this is 2K, this is 4K, and this is 3K, and this is 6K, and this is 1K. Let me call this as, because this is VP, let me call this as VP voltage, diode is connected to P, and this is what your VN. Just let me call this as. Therefore, this is what is your VP, or I can say anything is fine. Okay, this is what your VP, and this is what your VN. You find VP, you find VN, and then bring back your diode. Your diode is, at least it needs 0.7 to be on. That's what he told. It is on voltage is 0.7. It's not ideal. It is second approximation. Therefore, VP should be greater than VN at least by 0.7. Then only your diode will be conducting. Else diode will not be conducting. Now let's find VB. It is simply network analysis. This is what your 1 milliampere. Right? Now, how will you calculate? This is current division network, right? If it is open, there is no current which is flowing through this. It is simply a branch here, branch here. Therefore, let me call this as, both are black only. Okay. Let me call this as I1 and I2. Then tell me what your I1? Your I1 is nothing but opposite, right? Therefore, your I1 is equal to opposite resistor. Both are in series. 9K divided by, and this is 6K. 9K plus 6K, 9K plus 6K into, because this 1 milliampere is equal to I1 plus I2. This is what is your 1 milliampere. This is what is your 1 milliampere. Right? Therefore, now tell me, into 1 milli. Right? Therefore, 9K, K milli will be cancelled. Everything will be done. Sorry, K will be cancelled. Then 9 by 15. 9 by 15 milliampere. What is that? 3 3s are 3 5s are 3 by 5 milliampere, which is 0.6 milliampere. Okay, that is fine. Similarly, what is your I2? If you calculate, what is your I2? Your I2 is equal to opposite resistance, which is 6K divided by, actually no need to calculate, just to confirm, because out of 1 milliampere, 0.6 is going here, definitely 0.4 here. Okay, but just for the confirmation, 6K opposite resistance 6K divided by 6K plus 9K into 1 milliampere. Therefore, what is this? This is nothing but 6 divided by 15 milliampere. 3 2s are 3 5s are. Therefore, 2 by 5. This is 2 by 5 milliampere. What is that? Obviously 0.4 milliampere. No doubt about it. Because the total current is equal to 1 milliampere. No need to do, but just for your understanding. In the examination, don't do all these things. Because you understood, you have to solve it very fast. Done. Therefore, now let's calculate what is VP. Therefore, tell me what is VP. Therefore, VP is nothing but the current I1 into 4K. I1 into 4K. Therefore, what is I1? I1 is already calculated. 0.6 milli into 4K, which is nothing but 2.4 volt. Fine. Similarly, what is your VN? Therefore, what is your VN? VN is nothing but voltage at this point. I2 into 6K. I2 into 6K. What is I2? I2 is nothing but, we already calculated 0.4 milli into 6K. It is also 2.4 volt. What does it mean? Your VP is equal to VN. Therefore, VP is equal to VN means what is voltage drop across your PN junction diode? Voltage drop across PN junction diode is 0. At least we need 0.7. Then only your PN junction diode will be on. Therefore, now what we got to know? We got to know what is voltage across open terminals. Therefore, because since Vp minus Vn is equal to 0, the diode is off. When diode is off, what is your circuit? Then your circuit is simple. This is what your 1 milliampere. Same thing. This is what is this. This is what your Vp and this is what is your Vn. Both are same. This is what is 2 kilo ohm. This is what is 4 kilo ohm. And this is 3 kilo ohm. This is what is the circuit actually. Whether diode is there or not. Actually, this is balanced bridge. No, but I just gave you balanced bridge is 2 into 6, 12. 4 into 3, 12. Therefore, it is a bridge, kind of Wheatstone bridge. Therefore, balanced. Therefore, Vp is equal to Vn. Whether whatever you correct in between, nothing will happen because it is balanced. Vp is equal to Vn. Done. Fine. Therefore, what is Vp? Vp is known to you, which is 2.4. This is 2.4 volt. This is also 2.4. But ultimately, we want the current which is what is flowing through 4K. That is straightforward, right? Therefore, which you already calculated. That is nothing but what? 0.6 only. Therefore, 2.4 divided by 4K, which is 0.6 milliampere. Therefore, what is the answer? Answer is 0.6 milliampere. Answer is 0.6 milliampere. I hope everyone understood. Right? Done. Problem number 3. The output voltage of the diode circuit shown in figure is connected to an averaging DC voltmeter. The reading on the DC voltmeter in volts, neglecting the voltage drop across the diode is, means ideal diode. Okay, let's see. Problem number 3. Circuit is, this is what is our PN junction diode and this is what is our resistor. This is GATE 2017 and this is nothing but 10 sin omega t, 10 sin omega t, and frequency is 50 Hz. Okay, now this is 1 kilo ohm and this is what your V0. Okay, this is ideal diode. Now what is asking is, when a voltmeter is connected, this is what your voltmeter, what is the reading? Average reading is what? This is what is average voltage reading. Okay, this is what is given. First of all, you should find what is V0 with respect to Vi. Therefore, this is what your Vi, right? This is your input voltage. Vi is equal to 10 sin omega t. Whatever it may be, that is a voltmeter. It will have impedance infinity, that is not loading your load. That's fine. Now, if you know V0, then we can find what is average value of that. Okay, then problem is over. Now, if you treat this as Vi, actually this is nothing but what? I think we had seen this problem, right? Problem in the sense, the starting of the class. If I say this is what your Vi, when Vi is positive, that diode is on, all those things, right? You know already. Therefore, case 1, when Vi is greater than 0, because ideal diode, your diode is on. Open the diode, then you will get it. Okay, your diode is on. I am doing directly. When diode is on, this is what your Vi, right? Don't bother about type of input. Simply take like transfer curve, and this is what your R. Then tell me what your V0. See, Vi is in parallel to your load. Therefore, V0 is nothing but Vi. Simple. Now, case 2. When Vi is less than 0, when Vi is negative, then it is instead of plus minus, right? Therefore, this is what is positive. Now it is minus and plus, actually absolute value. Minus means your diode will be off, right? Then your diode is off. When diode is off, this is what is your circuit, right? There is no current flowing through the circuit, then the voltage drop will be 0. Your V0 is 0 volt. Therefore, tell me what your transfer curve. The transfer curve is nothing but this is what your Vi and this is what your V0. Therefore, the break point is 0 only. when Vi is greater than 0, your output is same as that. Then when Vi is less than 0, then this is what is our 0. Therefore V0 is 0 here, and here V0 is equal to Vi when the switching point is 0 or the break point is 0. Okay. Now if sine wave is applied, one sine wave, that is what is enough, 0, and then peak value is 10, minus peak value is minus 10. Then if this is what is given, what is your output? Your output will be, for the positive cycle only, it will pass as it is. When Vi is greater than 0, V0 is Vi. Vi is greater than 0, your V0 is Vi. It is passing as it is. When Vi is less than 0, your output is 0. Therefore, this is nothing but negative clipper. All negative voltage will be clipped. Right? Now, this is nothing but your half wave rectifier. This is nothing but your half wave rectifier output. Only the positive signals will be coming. Therefore, for this, when I say this is what your Vm, therefore, this is nothing but your Vm. Your Vm is equal to 10 volts. Then for half wave rectifier, right, where your output voltage will be something like this, and this is your Vm, then the average value, right, then the average value will be Vm by pi. This is nothing but your for half wave rectifier. For full wave rectifier, 2 Vm by pi, because you will get something like that. Therefore, this is what is your Vm by pi. Therefore, what is your average value? This is your V0. Therefore, what is average of V0 is equal to Vm by pi. What is Vm? 10. 10 by pi is around close to 3 volt. Because this is fill in the blank, you have to calculate accurately. That is 3.183. 3.183 volt. This is the answer. Okay, take it. Then we will solve problem number 4. Now, problem number 4. In the following limiter circuit, basically clipper, an input voltage Vi 10 sin 100 pi t is applied. Assume that the diode drop is 0.7, therefore V gamma is given, which is 0.7, and input voltage is also applied. What is that? 10 sin 100 pi t, 100 pi t. Girard breakdown Vz is equal to 6.8 volt. Then what is asking? The maximum and minimum values of output voltage respectively are. Straightforward. Okay, this is what is your circuit, and this is what is your PN junction diode, and this is what is your Zener diode. It is combination of PN junction diode and Zener diode, and this is what is our diode. Now we need to find what is V0. This is V0. Okay, this is diode D2, D1, Zener 1, which is 6.8 volt, and this is 1K, and now this is what is our Vi. Okay, asking for V0 max and min. Max and min. We will get transfer curve, then we will respond to actual input, then obviously we will get max and min. Okay, don't need to bother what type of input you have, whatever. If you get transfer curve, then problem is over. Okay, and these are all not ideal diodes, these are all practical diodes. Okay, now if you observe clearly using common sense, no need to open and do it, using common sense. D1 and D2 are opposite, no worry at all. Let us say when D1, D2 will be off when VA is positive, fine, but D1 will be conducting only when VA is positive, right? But Zener diode will be in reverse bias. Till what point it will be in reverse bias? Till the voltage across Zener diode is less than 6.8. If the voltage across Zener diode is more than 6.8, right? Then it will be in breakdown, and the voltage across the diode D1 should be 0.7. For 0.7 plus 6.8, which is 7.5. If your VI is more than 7.5, then this will be conducting, this will be in breakdown. Else it won't be in breakdown. Okay, let's see case 1. Maybe if you want, you can say open the diodes and you'll do it. Okay, but I'm skipping it, assuming that you're understanding, you're trying to follow me. Then tell me what is that? Let us say VI positive, VI negative. Okay, that's fine. But when VI positive, it should have 0.7, it should have 6.8. Else, even though this is on, this will be off, there is no path. Okay, then let us say when VI is greater than or equal to 0.7 plus 6.8, 7.5 volt, then your diode D1 is on, and GNR diode is in breakdown. GNR diode is in breakdown. If that is the case, then tell me what is the status of the circuit, and what about your diode D2? That is off, because for positive values D2 is off. It is off. Then what is your circuit? Your circuit is, your diode is on, your GNR diode is also on, this is 0.7, this is 6.8, that's it. And this is what your V0, right? And this is what your VI. This is what is 1K. What out maybe, what is your V0? Your V0 is equal to 7.5 volt. Done. Okay. Now, case 2. Less than 7.5, surely this is in reverse bias, off. Therefore, less than 7.5. Now, let's go. Less than 7.5, this is off. This is also off, but this will be conducting only for negative values, right? Therefore, now if you ask me in between minus 0.7, using common sense, minus 0.7 to less than 7.5, more than 7.5 is already covered. It's like I'm coming from plus infinity to minus infinity. You can go in that way, right? Then, or if you want to start, you can start from minus infinity and all those things. That is also fine. Therefore, minus 0.7 to 7.5. Less than 7.5, this path will be off. This is also off. But now tell me what should be the voltage at this point. When I say this is 0, it should be less than minus 0.7. Then only it will be conducting. Now all are off, you can say. Therefore, now you can say less than 7.5. We don't know, even though this is conducting, this is not conducting. Let us say your D1 is conducting. What it may be, all are off. This both branches are open circuit, are opened. If all are opened, then what is your circuit? Your circuit will be something like this. This is your V0 and this is your VI. If you observe clearly, this is 1K. Therefore, what is your V0? Your V0 is equal to VI, because nothing is limiting you. Your V0 is simply VI, because both are off. There is no current which is flowing. It is open terminals. Then simply V0 is equal to VI. Now case 3. What is case 3? When your VI is less than minus 0.7. Now you know only, that's what, only D2 is on. D2 branch is conducting. D2 is on. D1 is off, negative. Then fine, nothing. Therefore, what is your circuit? Only D2 is on. Therefore, it will have something like this. This is your VI. This is 1 kilo ohm. And this is what your V0. This is 0.7. Therefore, what is your V0? Therefore, V0 is equal to minus 0.7. Then if you draw transfer curve, what is your transfer curve? This is your VI and this is what your V0 with respect to breakpoints. The breakpoints are minus 0.7, minus 0.7, and positive side 7.5. This is what is your, let us say 7.5. Then tell me, in between minus 0.7 to 7.5 or less than 0.7, then your output is minus 0.7. then more than 7.5, your output is 7.5. In between, V0 is equal to Vi. That's it. Therefore, this is what is your minus 0.7 y-axis side and then 7.5. This is what is your transfer curve. Once you know the transfer curve, we can plot anything. Let us say now you can respond to actual input. What is your actual input? Your actual input is 10 sin pi t. Therefore, now your actual input, this is nothing but your 10 volt and this is what is your minus 10 volt. Now if you ask me what is your output, this is your V0. The breakpoints are 7.5 to minus 0.7. This is what is 7.5 to minus 0.7. In between it is tracking, after that it is saturated. This is what is saturated, but in between it is tracking. Therefore, this is also a clipper. Therefore, tell me what is your maximum value? The maximum value is 7.5 and the minimum value is minus 0.7. Therefore, the max is 7.5 and min is minus 0.7. Therefore, what is the answer? Which is what is matching to this? Minus 0.7 to 7.5, right? 7.5 to max is 7.5 then minus 0.7. Answer is C. Problem is over. See the same procedure, but when you solve multiple problems you will get it. I am skipping few things like how to find the status of diode. Directly I am taking this range. If you want to understand that also, you have to open and then try to see what will happen. Then you will get it. In the circle shown below, the knee current of ideal Zener diode is 10 milliampere. Knee current is nothing but IZ minimum is 10 milliampere. To maintain 5 volt across RL, the minimum value of RL, minimum power rating of Zener diode are respectively. Asking for RL minimum and the minimum power rating. Therefore, power rating, the minimum power rating of Zener diode. You should understand what is the meaning of this, right? Fine. Now VZ, output voltage. Therefore, VZ is nothing but 5 volt. That is what your output voltage. Now, if you see same circuit I am writing like this. Can I write like this? He has given like this, but both are same. This is nothing but your Zener regulator. This is nothing but 10 volts. Now this is 100 ohm. This is 5 volt Zener, and this is what your RL. Okay, and this is your IL. And this is your output voltage. Your output voltage is Zener voltage, which is 5 volt. Okay, done. So he is asking for RL and then minimum power rating of that. I'll explain what is power rating. First of all, let's find what is your RL minimum and all those things. Okay. See, that's what it is related to. For safe action or safe regulation operation, here what is the value of RL minimum? The minimum RL value such that it will be in safe. Safe means it will have regulation. Very simple, no confusion, but we know that this is what your source current IS and this is what your Zener current IZ and this is what your load current IL. Therefore, we know that IS is equal to, we know that Is is equal to Iz plus IL, equation 1. And what is your Is? Is is nothing but what? Input voltage Vi minus the GNR current or output voltage or GNR voltage divided by the resistance value Rs. Okay, that is fine. This is what is equation 2. These are all typical equations which we need for GNR regulator. Fine. Now, what do you want to find? Remember, whatever you want to find, first of all, what is RL? I want to find RL minimum. First of all, what is RL in terms of node 1? RL is nothing but your output voltage divided by load current. See, this is very important for writing. You see, your output voltage divided by your load current IL. Right? Therefore, what is your output voltage? If it is a regulator, your output voltage is GNR voltage, which is 5 volt. 5 divided by IL. This is what is your RL. But what do you want to find? You want to find the minimum load value. Therefore, what I do, your RL should be minimum. Tell me, when I say RL is minimum, this should be minimum. Therefore, can I say this is 5 only? For what value of IL, this will be minimum? Can I say when IL is maximum? When IL is maximum, your RL will be minimum. Right? Therefore, what I say, RL minimum. Right? Therefore, what is your IL? What is your IL? First of all, your IL is nothing but, from this can I write, IL is nothing but Is minus Iz. Therefore, it should be Is minus Iz. It should be maximum. Tell me, when is this maximum? Here it is load regulation, not line regulation. Your line voltage is constant. Your line current is constant, right? Therefore, what is that Is? Maybe if you calculate Is, what is Is? Is is equal to Vi, 10 volts, and Vz, 5 volts, and Rs, 100 ohm. Therefore, what is this? 5 divided by 100, 1 by 20, which is 50 milliampere. Therefore, Is is equal to 50 milliampere. Therefore, now if you substitute, what it may be? 5 minus your Is is 50 milliampere minus, that is maximum when Iz is minimum. When Iz is minimum. Therefore, 5 divided by 50 milli minus, what is Iz minimum? Already given, 10 milliampere. Then 50 milli minus 10 milli, 40 milli. Therefore, 5 divided by 40, that milli is becoming kilo ohm. Therefore, what is this? 5 divided by 5 8 which is nothing but 0.125, which is 125 ohm. Therefore, this is what is your RL minimum, the minimum load value, such that you will get regulation operation. That is what is your 125 ohm. I think first bit is over. Out of 2 bits, we have 2, right? First bit is over. Now, just listen, I'll give you time later to write down. Now, if you see here, I guess, is this problem number 5 or 6? Sorry, this is problem number 5, right? This is problem number 5, not 6. Okay? Therefore, now, RL minimum. Now, he is asking what is the minimum power rating of GNR diode. Minimum power rating in the sense, not minimum power dissipation. What GNR diode to be selected such that there is no damage of GNR diode. Let us say in this configuration, when Vi is 10, 100 ohm, having some load value, whatever it may be, right? The worst case scenario, if you take whatever maximum current which is what is flowing through the GNR diode, let us say it is giving some 100 milliwatt. Then the maximum power can be dissipated through GNR diode in this configuration is 100 milliwatt. If that is 100 milliwatt, then what is the minimum power rating? 100 milliwatt only. If I take 200 milliwatt GNR diode, what does that mean? It can handle 200 milliwatt of power dissipation. But worst case maximum power dissipation in the circuit will be 100 milliwatt. Then if I choose 200 milliwatt GNR diode, happy for me. It can handle up to 200 milliwatt. but the minimum power rating or the minimum power handling capacity of GNR diode should be equal to the maximum power dissipation what you have in the GNR diode. That much should be the minimum rating of GNR diode. I hope you understood, right? Therefore, what is minimum power rating of GNR diode? For the circuit, for the given circuit, the maximum power dissipation across the GNR diode. That is what you need to do, right? Therefore, write down second bit, minimum power rating of GNR is equal to the GNR maximum power from the circuit, PZ maximum from circuit. Okay, therefore what is PZ? First of all, PZ is nothing but voltage into IZ. Therefore what is PZ maximum? PZ maximum is true when IZ is maximum. What is VZ? That is known to you, into IZ. What is IZ? From the equation, IS minus IL. IS minus IL. This is what is your maximum. Therefore tell me, 5. Your IS is constant because your VS is constant. What is IS? We already calculated 50 milliampere. Therefore, this is 50 milliampere minus. When is this maximum? When IL is minimum. When IL is minimum. When you get IL minimum, what is your minimum load current if there is no load? Very simple. You remember I told IS is equal to IZ plus IL, right? If there is anything, ultimately to keep V0 constant, your IZ is the one which is what is taking extra current and then giving extra current to make V0 constant. If there is no load, extra current should be flowing through GNR diode such that it will maintain 5 volt. Therefore, maximum current will flow through it when IL is 0. Therefore, what is IL minimum? 0. Therefore, 5 into 50 milli minus 0 ampere. Therefore, which is 250 milliwatt under no load condition. Under no load condition. Therefore, under no load condition only, normally what we think, if there is no load, minimum power to the load, but the maximum power is across your GNR diode. That's why if you take any loudspeaker, right, if there is a load, when you are playing something, then only there is a power which is what is delivered to the load. Then what we think, if you don't play anything, right, power dissipation is 0. No, maximum power dissipation will be there across the active devices. Similarly, across the GNR diode, maximum power if there is no load. Okay, therefore this is what is your PZ maximum from the given circuit, 250 milliwatt. Therefore, this is what is the maximum power dissipation which you are seeing in the given circuit. Worst case is nothing but no load, 250 milliwatt. Therefore, what should be the minimum power rating of GNR diode? We have to choose a GNR diode such that it should have a power rating of 250 milliwatt. It can be more than that also. It can be 350 milliwatt. It can handle up to 350 milliwatt. But we need only 250 milliwatt. That is what we got the worst case from the given circuit. Therefore, the minimum power rating. Therefore, minimum power rating of GNR diode to be chosen is nothing but 250 milliwatt. Therefore, what is the answer? Answer is B. Answer is B. Take it. Then we will see next problem. The transistor shunt regulator in the figure has regulated output voltage of 10 volts. Therefore, V0 is equal to 10 volts. When input is varying from 20 to 30, the relevant parameters for the GNR diode, VZ is 9.5, VBE is 0.5, beta is 99. Neglect the current through RB, 0. Maximum power dissipation, therefore PZ maximum. What? And maximum power dissipation across the transistor. Actually, it is given as PT. Okay, that is what is your transistor watt max. Okay, that is what the circuit is. This is what is your GNR diode. This is your shunt regulator, okay. This is 20 ohm. This is your VI. And this is your RB. Okay. And this is what is 9.5 volt. And this is your IZ, GR current. And this is what is your V0. Ultimately, this is what your V0. V0 is equal to 10 volts. That is what is given. Okay. VI is equal to 10. Then is asking this. Okay. I think complete information is given. Now, how will you solve? We have only 2 to 3 minutes for the session. You think about it, then we will see how to solve the problem in the next session. But I will give you a hint how to solve the problem. Okay, we will continue in the next session. If you see here, first of all, what do you mean by PZ? Power dissipation. PZ, the power dissipation is nothing but VZ into IZ. Simple. This is equation 1. Okay, VZ is already known to you. If you know IZ, problem is over. Then similarly, what is your power across the transistor? Power across the transistor is nothing but VCE into IC. What is IC? This is what your IC, right? And this is what is your IB. And this is what is your IE. This is what your transistor. But what is your VCE? Your VCE is nothing but your V0, which is nothing but your what? 10 volts. VZ is nothing but 9.5. And this is nothing but your 0.5 because VBE is 0.5. This is already given. This is what your 0.5. That's for 9.5 plus 0.5, 10. Therefore, now this is nothing but 10 into IC. That is nothing but your IC. This is what is equation 2. This is what your transistor. Then what is VZ? VZ is nothing but 9.5. That is also not known to you. Therefore, if you know IZ and then IC, problem is over. If you know IZ and IC, problem is over. Try to solve how to get IZ and then how to get IC. If you know that, problem is over. Okay, done. We'll continue in the next session. Thank you.